Hi, good morning everyone. Today I would like to teach you on the chapter 3 Fourier series. So this Fourier series is the exponential type of the Fourier series. So in order to reduce the size of the video, I will just teach you on the important slide, and those you can just read the notes. Fourier series is a periodic signal which is represented as a function of the frequency. So Fourier series can be obtained for a periodic signal. So Fourier transform, in which you will study in chapter 4, is used for the periodic and non-periodic signal to obtain the frequency domain of the signal. Fourier series can be represented in the expression. It's a formula that is the fx equal to the a0 plus the summation of the an cos nx plus bn sin nx. And this a0, an, and bn, we call it as a Fourier series coefficient. Okay, in order to find the Fourier series coefficient, we need to find what is the formula. So later on, I will show you what is the formula of this coefficient. As I told you just now, the Fourier series is used for the periodic function. Okay, periodic signals. So for periodic signals, do you know what is periodic? Yes, the signal will be repeated again and again. Okay, the repeated signal is that sinusoidal signal. It's a repeated sinusoidal signals. But what about the non-periodic? Non-periodic is just like my voice now, my voice. So even though I repeat the same statement, but I won't use the same intonation to talk to you. So this voice is a non-periodic signal. When you talk about the periodic signal, you always have to know what is the fundamental periods when the signal repeat again. So fundamental period T0 is the minimum value of the signal repeat again and again. Then fundamental frequency is we define as omega naught equal to 2 pi f naught, or you can say 2 pi over T naught. T naught is the fundamental period. Okay, so F naught is F equal to 1 over T. Next that you need to know is the complex number and the Euler relation. So this is the complex value A plus JB that you need to know is J equal to square root of the minus 1. And then how to get the real number. So this is the real number. And this is the phase. Okay, the phase. The phase is the inverse tangent B over A. So you get this value. And this is the Euler formula that you need to know the formula. This is the exponent J theta equal to cos theta plus J sin theta, or exponent minus J theta is equal to cos theta minus J sin theta. So this formula you need to know. Okay, or we name it as a or you have another formula is cos theta equal to exponent J theta plus exponent minus J theta over 2. This one is sine. Okay. In the chapter Fourier series, you have three types of the Fourier series: exponential, trigonometry, and amplitude phase Fourier series. Now let's go through the example 1, the exponential Fourier series. Given a signal xt equal to the 3 cos pi over 3t, and what is the Fourier series coefficient? Okay, do you still remember cos theta is referred to what? Do you still remember the Euler formula for the cos theta? Yes, that's right. The Euler formula, that is the cos theta equal to exponent j theta plus exponent minus j theta over 2. So this is the Euler formula that you need to convert the cos into this exponential function. Okay, now let's look at together. your xt is the 3 cos pi over 3t. Okay, as you know from the Euler formula, cos omega naught t is equal to half of the exponent j omega naught t plus exponent minus j omega naught t. So this is the formula. So in order to find the xt, so that is you have 3 cos, right? So you have 3 cos is half, and then you have exponent j omega naught. Okay, omega naught is what? You need to know the omega naught. Okay, what is the omega naught in this case? If you look at here, pi over 3. So this is the omega naught. So it's pi over 3t plus exponent minus j pi over 3t. Alright, so you will get 3 over 2 exponent j pi over 3t plus 3 over 2 exponent minus j pi over 3t. So this is the expression for the xt. And then do you know what is the fundamental period for this cos pi over 3? Okay, let's look at this. T naught equal to 2 pi over omega naught, right? So omega naught, as you know, is pi over 3. So that is equal to? Yes, 6. So this is a periodic signal. So here, you know that this one is the discrete frequency. So do you have two discrete frequency? So what is the Fourier series coefficient? So Fourier series coefficient. So x1 is equal to, if you look at this one, is 3 over 2. X minus 1 is 3 over 2 also. So x1 is 3 over 2 and x minus 1 also 3 over 2. So when you plot it, you can plot it the magnitude, the xn, 3 over 2 and 3 over 2. So this number are the real value. Then if you look at the second example, if my xt is equal to 3 sine pi over 3t. So what is the coefficient? What is the Fourier series coefficient? Okay, sine. So you have this. Okay. So this is a odd signal. Odd signal. So as you know, for the Euler formula, the sine omega naught t is 1 over 2j exponent j omega naught t minus exponent minus j omega naught t. So again, this is the formula. When you write down, is 3 times with 2j exponent j pi over 3t minus exponent minus j pi over 3t. So it's 3 over 2j. And yes. Okay, so you need to remember that when you bring the 1 over j to the up is equal to minus j. So when I simplify, I will have this kind of answer. And then, okay, this is the expression for the x-did, but what is the coefficient? Coefficient is the magnitude. This is the magnitude here. That if you look at this one, this is the j. It's not real. This is the imaginary. So this x1 and x minus 1 is the imaginary value. Okay, so you plot the imaginary. So x1 is negative 3j over 2 and x negative 1 is 3j over 2. So my plot negative 1 is 3j over 2 and another one is negative 3j over 2. Okay, that's all for today and thank you for watching.